This video will review over mass stoichiometry problems. Here we have a mass problem. In a mass problem, we calculate the number of grams of one substance that is required to react with or be produced from a given number of grams of a second substance. So as we look at this equation, we will have our given mass of chemical A. We'll have 1 mole of A over the weight of chemical A from the periodic table. We multiply that times our coefficients from our balanced chemical equation. Coefficients for chemical B will be on top. Coefficients for chemical A will be on bottom. We multiply that times the weight of chemical B from the periodic table over 1 mole of chemical B. Our masses of chemical A will cancel out. Our moles of chemical A will cancel out. Our moles of chemical B will cancel out, leaving us a final answer in grams of chemical B. In this problem, we have the question, what is the mass of mercury produced from the decomposition of 1.25 grams of orange mercury 2 oxide? The molecular mass of mercury 2 oxide, or the weight from the periodic table, has already been given to you in the problem. So this is the weight of mercury 2 oxide right here from the periodic table. What we need to do is we need to identify chemical A and chemical B. So as we look at this, mercury 2 oxide will be chemical A and mercury will be chemical B. So here we have chemical A and here we have chemical B. We will convert the mercury to moles using the molar mass and convert the moles of mercury to moles of mercury oxide, and then finally convert moles of mercury oxide to grams of mercury oxide. So using the equation that was 2 slides back, we have our given mass of mercury oxide. We have 1 mole of mercury oxide over the weight of mercury oxide from the periodic table. Right here we have our coefficients. You'll notice that mercury oxide has a 2 coefficient, mercury has a 2 coefficient, and therefore we have those numbers to represent the coefficients. We have 1 mole of mercury. We have the mass of mercury from the periodic table. Notice that our grams of mercury oxide cancel out. Moles of mercury oxide cancel out. Moles of mercury cancel out. We do the math, and our answer would be 1.16 grams of mercury oxide. One final example. How many grams of nitrogen monoxide is produced if 12 grams of oxygen is combined with excess ammonia? Notice that we have our balanced equation. The excess ammonia means that we will ignore this in our chemical equation. As we look, we will identify oxygen as chemical A and nitrogen monoxide as chemical B. We will plug our numbers into our equation. 12 grams of oxygen, we got that from our problem. 1 mole of oxygen over the weight of oxygen from the periodic table. Now do notice that it is 32, and that is because oxygen is diatomic. So we have 2 times 16, or 32 is the mass. We have 4 moles of nitrogen monoxide over 5 moles of oxygen. Notice that that is due to our coefficients. And then we have the mass of nitrogen monoxide over 1 mole of nitrogen monoxide. Notice again our units are canceled out. We do the math and we have 9.0 grams of nitrogen monoxide. If you have any additional questions or concerns about this problem, feel free to stop by and I will be glad to help you.